Why can a dim blue light knock electrons out of a metal instantly, while a blazing red light can shine forever and still eject nothing? In the energy filament theory, the electron is not a free marble waiting to be pushed. It sits behind a hard exit threshold inside a shallow tension basin, and light arrives as discrete coherent wave packets whose per packet spec is set by color, while intensity mainly sets how many packets line up at the door. The mainstream slogan energy equals frequency times a constant is correct as bookkeeping, but it can leave you with no picture for why intensity doesn't help. So use a nightclub image. The electron is inside. The metal's binding environment is the building. The working function is the bouncer's minimum requirement. If everyone outside is underage, you can make the line a mile long and it still won't produce a single entry. That is red light in this story, not weak as a beam, but too soft per package. A red wave packet has a slower rhythm signature, so each individual packet carries too little punch to clear the threshold. Crank up intensity and you're not upgrading the Passcard. You're only sending more people to the same bouncer with the same invalid ID. They got turned away one by one. Switch to a bluer rhythm and each packet is inherently harder in the only way the threshold cares about. Then you don't need waiting, because nothing needs to accumulate. The first packet that lands under the right coupling conditions triggers a closure event and the accounting clicks immediately, ejecting an electron. That single picture reproduces the 3 annoying laws that embarrassed classical wave thinking. There is a color threshold. Wrong Passcard, no entry, no matter how bright. Emission is essentially immediate. It's not slow charging. It's one packet arrives, meets the requirements, threshold closes, done. And intensity changes the count, not the max energy. More intensity means more packets per second. So you get more closure events per second, which is higher current. But the kinetic energy per electron is set by how far above the threshold each packet is. And that depends on color, not on how crowded the line is. If someone tries to pull you into the field amplitude squared explanations, translate it back to the door. Intensity is shipping rate. Color is single box specification. Shipping faster doesn't change what's inside each box. The final piece that makes the effect feel inevitable is the wave versus discrete split. During travel, light behaves like a wave because it is a wave packet relaying through the energy sea. At the boundary, the interaction is discrete because the boundary is a thresholded ledger. Each closure is one settlement, one click, one electron out. On the road you see waves, at the door you hear ticks. The punchline is simple. Color decides whether the threshold can be crossed, and intensity decides how many packets per second get to try. Next up, Compton scattering. When light scatters off near free electrons, why does a bigger scattering angle make the outgoing light redder, as if it paid more for the turn? Tap follow, share it on New Physics, Clear Universe.